Hi, welcome back to our next video. In the previous video, we proved the law of conservation of momentum and used two example problems to verify the law of conservation of momentum by using before numbers and after numbers and seeing that the total was the same. So we discovered that the law of conservation of momentum states that the total momentum of a system doesn't change, which means that the total momentum before the collision is equal to the total momentum after the collision. So P total before equals P total after. Okay. So we're going to use we're going to use a couple of questions here and use the law of conservation of momentum to determine the velocity of objects after they collide and stick together. So let's look at question number 1. A piece of Play-Doh with a mass of 4 kilograms is moving at a speed of 3 meters per second. It collides with another piece of Play-Doh with a mass of 2 kilograms that is stationary. If the two pieces of Play-Doh stick together after the collision, what will their velocity be after they collide? So we have one piece of Play-Doh that has a mass of 4 kilograms, and it collides with another piece of Play-Doh that has a mass of 2 kilograms. The 4 kilograms is moving at a velocity of 3 meters per second. We assume it's to the right because the sign is positive. And the 2 kilogram Play-Doh is stationary. After they collide, we're going to have one jumbo piece of Play-Doh moving at some velocity. And that's what we need to figure out. And we're given 5 answer choices that we have to work towards. So let's set up what we know into boxes. The chart will help us as we learn how to use the law of conservation of momentum to solve these problems. So we have our M1 and our V1. So we have mass of the first object is 4 kilograms, moving at 3 meters per second. And our second object has a mass of 2 kilograms and is stationary, 0 meters per second. So now we calculate the momentum of each object before the collision. So we have, remember, multiply, multiply, add. So we're going to multiply 4 times 3, that's 12 kilogram meters per second. And we have 2 times 0, which is obviously 0 kilogram meters per second. If an object isn't moving, then it has no momentum. We add those two momentum together, and we get 12 kilogram meters per second. That's our total before the collision. The law states that the total before the collision is equal to the total after. So we're going to carry that across. If the total before was 12, then the total after has to be 12 kilogram meters per second. Total stays the same. Okay. Now we have to work up the right-hand side. We know after they collided, those Play-Doh pieces are sticking together. So we had a mass of 4 kilograms stuck to a mass of 2 kilograms. Now we have a mass of 6 kilograms. So we have 6 kilograms of Play-Doh now stuck together, traveling at some unknown velocity. So now we need to ask ourselves, if these two numbers have to get multiplied together to get 12, then 6 times what is equal to 12? And you should be able to answer that question pretty easily, that velocity is going to be 2 meters per second. So we have a 4 kilogram piece of Play-Doh moving at 3 meters per second, sticks to a 2 kilogram object that's stationary. They stick together. After the collision, we have one gigantic mass traveling at one velocity, and that velocity is 2 meters per second. So our answer then would be B. So we use the law of conservation of momentum to determine the motion of an object after the collision. Let's do another one and practice again. Okay, so here's our second question. A toy train car has a mass of 2 kilograms, is moving to the right at a velocity of 4 meters per second. It collides with another toy train car that has a mass of 7 kilograms, moving to the left at 5 meters per second. Okay, so we had 2 kilograms and 7 kilograms. That's before the collision. After the collision, if the train cars get hooked together, so train cars are connected together, so they travel as one long train down the tracks. If they're hooked together after the collision, what will their velocity be after the collision? So what's the velocity after the collision? And we have, again, 5 answer choices. So let's set up our numbers in our equation. Get rid of that. So let's set up our numbers. So we have the first train car has a mass of 2 kilograms, moving at a velocity of 4 meters per second to the right. The second train car has a mass of 7 kilograms, traveling to the left at 5 meters per second. Now we need the negative in there. Negative is for the left. It says left, we need a negative. So then we can figure out our momentum for each one before the collision. Multiply, multiply, add to get the total. So 2 times 4, that's 8 kilograms. Oh, sorry, kilogram meters per second. Then you have 7 times negative 5. That's negative 35 kilogram meters per second. And then I'm going to add them together. So multiply, multiply, add. 8 plus negative 35 equals negative 27 kilogram meters per second. That's our total before the collision. Remember, the law says that the total stays the same. Total stays the same. So I have a negative 27 kilogram meters per second for my total after. It's the law. The bottom boxes in this chart have to be equal to each other if we're going to use the chart. Now we have to work up the right hand side. So we have those 2 train cars that are now stuck together. One had a mass of 2, one had a mass of 7, so we have a total mass of 9 kilograms here. So if we're going to figure out that velocity, and we know the mass and we know the momentum, then we have to ask ourselves 9 times what equals negative 27. And the answer then would be negative 3 kilogram meters per second. Nope. Negative 3 meters per second. So after they collide, they're moving at 3 meters per second, combined now to the left. So those train cars are going to collide and now move in the left direction. So we've been able to use the law of conservation of momentum to determine the motion of an object or objects after a collision. And that's our learning target. I can determine the motion of an object or objects after an inelastic collision using the law of conservation of momentum. So you're going to practice with more of these in class. Rewatch the video as many times as you need to until you get the process down. But keep practicing, and we'll check you out again on another video. Thanks.